All right, so now let's talk about section 5.4, which is going to introduce to us other trig functions. As with my other videos, these tend to be a bit longer. But remember, on the MyOpenMath, there are links to very short video clips. So if you like things that are a bit shorter in length, please feel free to refer to those. Okay, so again, as with before, I'm going to assume that you are reading the sections in the book and that this is just an overview for you. All right, so the first thing I want you to note is that the sine and the cosine are ratio of the sides of a right triangle in a circle. Okay, so if I'm looking at a circle and I form the ratio of these sides, this is r, this is x, and this is y. This is theta. We know that the sine is y over r, and the cosine is the ratio of the sides x over r. Okay, but there are other combinations to form a total actually of 6 trig functions. Okay, we've already really honed in on 2 of the 3 that we're going to. Okay, but we've looked at y over r, we've looked at x over r. I'm going to define 4 other trig functions. Tangent of theta is the ratio of y over x. These are our 3 main trig functions. This will be the focus of our class. Of that, I'm for sure. But there are 3 other trig functions. We have what's called the cosecant of theta. And instead of being y over r, it's r over y. We have the secant of theta, but instead of looking at that as x over r, it's r over x. And we also have what's called the cotangent of theta. And instead of the ratio of y over x, it's just the ratio of x over y. Couple relationships that I want you to notice. Notice that the sine and the cosecant are reciprocals of each other. The cosine and the secant are reciprocals of each other. And the tangent and the cotangent are reciprocals of each other. The other thing that I want to show you is that the tangent, and this is a really important relationship to know, is the sine value over the cosine value. If you don't believe me, check it out. My sine is y over r. My cosine is x over r. And when you have a fraction divided by a fraction, you take the top guy and you multiply it by the reciprocal of your denominator. Notice you get y over x, which is the tangent. Okay. So you can also say that the tan is sine over cosine, and in a similar manner, since the cotangent is the reciprocal, that's the cosine over the sine. But these are the 3 main ones that we're really going to hone in on. All right, now one thing I want you to note is, geometrically speaking, and those of you going on to calculus, this is a really cute little thing to notice, is that the definition of our tangent corresponds to the slope of the line between this value, our origin, and our xy, right? If I wanted to find the slope of the line, it's the change in y values. So y minus 0 is y over the change in x values. So one thing that I want you to notice is that the definition of the tangent function corresponds to the slope of the line from the origin to that point. Okay, so that's pretty darn cool. You'll remember that when you get to the when you get to calculus. All right, now there's a lot of other identities that we have. Recall we have the Pythagorean identity that sine squared plus cosine squared is 1. Well, I could say, I wonder what would happen if I divide everybody by the sine squared of theta. Well, sine squared over sine squared is 1. Cosine squared over sine squared is cotangent squared. And 1 over sine squared is cosecant squared. Is this an identity we use a lot? No, but it's a good one to know. And notice it just comes straight from our Pythagorean identity. Similarly, I could divide both sides by cosine squared. Sine squared over cosine squared is tangent squared. Cosine squared over cosine squared is 1. And 1 over cosine squared is secant squared. So just like we have this relationship with our sine and our cosine, we have very similar ones with our cotangent, cosecant, as well as our tangent and our secant. These are just other forms of the Pythagorean identities. All right, so let's just play around a little bit. So suppose I tell you that the secant of theta is -7/3 and theta is between pi over 2 and pi. I want us to find the tangent of theta and the sine of theta. Oh boy. All right, let's do it. This tells us the quadrant. We're in our second quadrant. It's between pi over 2 and pi. Okay. Now, there's so many different ways we can do this. It really doesn't matter how we go about doing this. But one thing we can say is if we know the secant, we know the cosine. Because the cosine is the reciprocal. So I have that the cosine of theta is -3/7. Notice I wasn't asked to find the cosine of theta. I was asked to find these guys. Well, from here, we can use these Pythagorean identities. We can say, well, sine squared plus cosine squared is 1. And we can solve for sine that way. Or we could have drawn that right triangle like we did before. So let's just continue with this. So we get 9 over 63, or excuse me, 9 over 49. I do know how to multiply. So then I'm going to get that sine squared theta. Well, move the 9 over 49 over. I get 40 over 49. Take the square root. Is my sign positive or negative in the second quadrant? It's positive. So the sine of theta is the square root of 40 over 7. Now from here, we got that guy. We want to find our tangent. 2 ways to do it. You could say tangent is sine over cosine. So we could literally look at that ratio. Or you could say, well, I know that the tangent squared plus 1 is secant squared. Either way you do this, you're going to get the same result. Okay, I'm just going to look at it as my sine over my cosine. So I have the square root of 40 over 7 times -7/3. So notice I get the square root of 40 over 3. Notice it's negative, but that makes sense. Okay. Remember, your tangent is your y over your x value. And our x value is negative here. All right. So what if I tell you that theta is 5 pi over 6? Well, if theta's 5 pi over 6, again, normally I'm never going to ask you to find anything other than sine, cosine, tangent. But just for the fun of it, let's just do a couple of them. Let's find the exact values for our secant. We're just going to be funny here. Cosecant, tangent, and cotangent. Okay, we want to find the exact values. And when we say exact values, it means, leave it in the square root form. Okay, well, we know how to find our sine and cosine. Let's do it. What quadrant are we in? We're in our second quadrant. So how do we find our sine and our cosine of 5 pi over 6? Well, this is a reference angle thing from our previous section. Our reference angle is pi over 6. I know that my sine of pi over 6 is 1/2. And my sine is positive in my second quadrant. I know that my cosine of pi over 6 is √3 over 2. But notice I'm in my second quadrant and my x value is negative, so my cosine is negative. Well, if the cosine of 5 pi over 6 is negative √3 over 2, then the secant is just the reciprocal of it, negative 2 over the square root of 3. Or you can write that as negative 2 √3 over 3 if you want to rationalize your denominator. The sine of 5 pi over 6 is 1/2. So the cosecant is the reciprocal, or 2. All right, we know our tangent is our sine over our cosine, and 1/2 over negative √3 over 2 is negative 1 over the square root of 3. And you can rationalize your denominator if you want. And then the cotangent is just the reciprocal of that, so negative √3. Okay. So I definitely encourage you to play around with these as much as you can. There is no such thing as doing too many examples and practicing too many times. Okay. So suppose I tell you, slightly different example, that the sine of theta is 3/4 and I'm in quadrant 2. I want us to find the cosine, the tangent. Let's do the secant, cosecant, and cotangent. This is a pretty sweet little one. Okay. So sine is 3/4. Notice I'm in quadrant 2. I'm going to play with my reference angle. Sine is y over r. I need to get this value here. I can use my Pythagorean theorem, and I claim I'm going to get the square root of 7. Okay, you don't believe me? Please go for it. Okay, so what is the cosine? Well, it's x over r. Notice you're in your second quadrant though, so it's negative. The tangent is y over x. So negative 3 over the square root of 7. All right. Well, what's the secant? The secant is just the reciprocal of this. So negative 4 over the square root of 7. The cosecant is going to be 4/3. And we could rewrite this as -4√7/7. And then the cotangent is going to be negative the square root of 7/3. All righty. We can do a similar one. Suppose I tell you that the tangent of something is 12/5 and I'm in my first quadrant. I claim I can find my other trig values. Tangent is y/x. We can use our Pythagorean theorem here to find the length of our hypotenuse, which is 13. So my sine is 12/13. My cosine is 5/13. And then in order to get our cosecant, our secant, and our cotangent, we can just flip all of those. All righty. So just to play around with the relationships between these, I'm going to do, what if we want to simplify the cosecant of t times the tangent of t? This might look stupid, but this is just a matter of playing with the relationships. My hint to you, put everything in terms of sine and cosine. Okay, secant is 1 over the sine. The tangent is the sine over the cosine. Those cancel, we get 1 over the cosine, which is the secant. Is this something to memorize? Absolutely not. Okay, you're just playing around with the relationships. What if I want us to simplify the secant of t minus the cosine of t over the sine of t? Well, this is already in terms of sine and cosine. So what I would do is I would say the secant is 1 over that. Well, what do we do now? What I would say is let's get a common denominator in my numerator. Do you agree I can multiply this by cosine over cosine? And then I'd have a common denominator here. So that becomes 1 minus cosine squared of t over the cosine of t. That's my numerator divided by the sine of t. All I did is get a common denominator. Cosine is cosine squared. Well, friends, if sine squared plus cosine squared is 1, I can scoot my cosine squared over, and I claim that 1 minus cosine squared is the same as sine squared. Right? Well, I have sine squared over cosine, and I'm dividing that by sine, so it's times 1 over the sine. That cancels with one of those. And I'm left with sine over cosine, which is tangent. This is really fun. It's just a matter of playing with these relationships. Okay. Want us to do just a couple more. What if I want us to simplify sine squared t plus cosine squared t over cosine squared t? Now, our temptation is to just cancel those. You can't do that because we're adding in our numerator, but I know that sine squared plus cosine squared is 1. And 1 over the cosine, we know, is the secant. Now, the next thing that we're going to do in this section, and we're just going to practice a few examples here, are as follows, okay? We're going to prove some identities. And when you want to prove identities, you're already told, hey, these things are equal. You're not solving anything, okay? You just want to verify, not solving, just verify, okay? And my hint to you is always, quote unquote, attack the more complicated side, okay? But you don't jive the two sides, you work them independently of each other. So for example, I'm going to tell you sine squared theta over 1 plus cosine theta is equal to 1 minus cosine of theta. I know this to be true. What I want us to do is verify this. In other words, show that this is true. Okay, so my hint was approach the more complicated looking side. I think you'll grant me that this is more complicated than this side. So I'm not going to talk about this over here. We're only going to look at this guy. Okay, so what do we know? Well, it would be really nice if we just had one trig function here, because we were really just left with one trig function over here. Can I write sine squared in terms of cosine squared? You bet. Sine squared is 1 minus cosine squared. Sine squared plus cosine squared is 1. Okay, you're going to want to look at all different permutes of that. Oh my goodness, happy algebra. This is the difference of two squares. We can factor it. It's 1 plus cosine theta, 1 minus cosine theta. Don't forget about your algebra. Now, since I'm multiplying here, I can cancel those. And notice I was left with 1 minus cosine. All right, let's do another one. What if I want us to prove that the secant of alpha minus the cosine of alpha is equal to the sine of alpha times the tangent of alpha? Now, neither one of these sides are very beautiful, but once you're adding or subtracting, I claim by definition, it's going to be more complicated. Okay. I mean, I could rewrite this because I know that this is sine and this is sine over cosine. So I could say that my right-hand side is sine squared alpha over cosine of alpha. Well, what can we do here? We could say this is 1 minus the cosine minus the cosine. What do our instincts tell us to do? Get a common denominator. Okay, so cosine alpha over cosine alpha. So I claim I have 1 minus cosine squared alpha over cosine of alpha. And we know that 1 minus cosine squared is sine squared. Okay, I want you to notice the techniques that we're using. We're rewriting things in terms of sine and cosine. We're getting common denominators. Okay, one more for now. I want us to verify this identity. 1 plus the cosine of u over the sine of u is equal to the sine of u over 1 minus the cosine of u. Again, I'm telling you, this is true. Verify it. Now, in this case, I don't think that one side is more or less complicated than the other side. I think that they both look terrible. Okay. But I know that there's ways to write sine in terms of cosine or cosine in terms of sine. again, most important thing I think in this whole class is sine squared plus cosine squared is 1. Okay. So for no good reason, I'm going to say I want to get rid of this 1 minus cosine u down there. Okay. Here's a technique. And if you're like, I wouldn't have thought of it, that's why I'm here, to somehow help you. Okay. If you want to clean up your right side, what I would say is multiply and divide by essentially the conjugate of this term. Instead of 1 minus cosine u, do 1 plus cosine u. Okay. Why? Well, let's do this. We get sine u times 1 plus cosine u over 1 minus cosine u times 1 plus cosine u. Well, what happens? Let's multiply out our denominator. 1 plus cosine u minus cosine u cancels. And then we have the cosine squared. And 1 minus cosine squared is sine squared. Well, this guy is going to cancel with one of those, and we have it. If you wanted to approach the left-hand side first, what you would do is multiply and divide by 1 minus cosine. All righty, have a ball.